Hello everyone, if you're here, I guess you want to know something about generics, covariance and contravariance. First of all, don't get scared by these difficult sounding names, covariance and contravariance, which are taken from theoretical physics. Actually, in the meaning of Java programming, there's no mathematics, there's no complicated physics involved. It's just about writing clean, extensible code as usual. So, maybe whoever decided for these terms was a major in physics like me, and maybe was feeling just like me a little bit nostalgic about his academic background. But actually, once you know what they mean, these terms make for very concise and effective ways to remember and communicate the ideas. So as usual, let's try to understand through an example. I've taken the liberty of creating a few very simple classes so that you don't have to suffer through seeing me typing very trivial stuff. I have created this class animal, which just holds a color as this method breathes, and I've created another class called feline, which extends animal, and finally another class called little doggy, which extends animal as well, and tiger, which extends feline. So basically, we have a little inheritance hierarchy with animal at the top, then feline, which is extended by tiger, and also we have a little friend, little doggy, which is of course not a feline, so it doesn't extend feline, it extends directly animal, and this little friend of us will be useful to explain an important concept later on. So I have also a class that I've called main because it's just a holder for my the entrance point of my program, for my main function. And as of now, the main function just creates a feline, but it does so in a polymorphic way. So you can see that the reference is of type animal, and the object is of type feline. And this should not shock you in any way because we already discussed polymorphism. If you have not seen my videos on polymorphism, I advise you to do so if you don't have already a background in polymorphism. So if you do have a background in polymorphism, you know that using a child class where a base class was expected is kind of a natural of the default behavior that we expect from an object-oriented program language like Java. And this is actually how the covariance is defined. Covariance simply means varying the type of the classes in the natural way, in a covariant manner with what naturally happens in an object-oriented programming language. Varying the classes as it naturally happens with polymorphism, using child classes where base classes are expected. And you also know that this is actually the simplest way to explain polymorphism and covariance, but if we can do this, we can surely do something a little bit more interesting, that's actually having, like in this case, a function that takes an animal as a parameter, but it actually can receive as an argument, that is, as the thing that's actually passed to this function, it can receive not only an animal, like we see here, which is pretty obvious, it can only receive any kind of object as long as that object is of a class that extends the class animal. So for example, I can pass it a new tiger and nothing wrong will happen or will be signaled to me by the compiler. Or of course, I can pass a new feline. There we go. And this is all nice and simple, but let's try to extend these ideas a little bit. And in particular, let's try to understand if there is any kind of covariance or contravariance when using generics. So let's use a very simple generic class like list. Say control space to import a list, and let's say we want to create a list of feline object, which we will call the felines, I guess, as a reasonable name, and it will be equal, and let's use array list as an implementation. No, array list of feline. So Now, maybe you already know what I'm going to do next. What about another function that's also static, because I'm going to call it directly from the main function, public static void, and we'll call it flist, because this flist is going to take not an animal, but a list of animal as an input. There we go. We call it LA. And now my question is, will I be allowed to pass this list of feline where a list of animal is expected, as I was allowed to pass a single feline where a single animal was expected? That is, can I do covariance on the generics type? Can I pass a list that's specializing on the type feline when I expecting the list that's specializing on the type animal? Can I do covariance on the type that the generics is specializing onto? Well, let's try it out. What do you think about it? I suggest you think a little bit about yourself before looking at what happens right now. So, what do you think? What do you think is going to happen? Is it going to be allowed or not? From an intuitive point of view, it kind of makes sense, exactly like it makes sense for the single class. So we might expect that it might work. Let's try it out. So let's see. Let's try flist of felines. And actually, the compiler doesn't like it. We are not allowed to pass a list of feline where a list of animal is expected, as we can see from this error message. Well, that's too bad, because actually we can figure out use cases where this kind of method could be useful even for list of other kind of classes, as long as they extend animal. So for example, let's imagine that this function is doing just for each on the list. So we say for each animal A in LA, we will just say A.breathe, and let's make this animal breathe. And this function could be useful also for a list of felines, for a list of little doggies, for a list of any kind of animal, which of course will have the method breathe. But well, we're not allowed to do this. We'll see if there's a workaround, if there's a better way in a few minutes. But for now, let's just accept that generic type are not covariant. So we cannot use a generic type on a child class, like feline, where a generic on a base class is expected. And this is our first important point. So now, let's comment out this line, and let me ask you another question. What about arrays? What can we do about arrays? Are they covariant or not? Because we know that arrays also specialize on a type. So for example, we can create an array of feline object. Let's say feline array. Let's say feline array. It's written properly like this. And let's say that we have 8 felines. Oops, sorry. So we have this beautiful array of 8 felines, and let's say, what if we have another function, static void, and we call it farray, which will take an input, you already know where I'm going, an animal array. Now, if I were to ask you, well, can I invoke this function farray passing a feline array, and noting that actually this function wants an array of animal, and this is not an array of animal, this is an array of feline objects? Well, you could apply the reasoning that we did before and say, well, probably if I cannot do it with a list, I cannot do it with array, and after all, I could not do it with list also because if you think about it, even if even if it makes sense intuitively, the main problem is that I cannot do polymorphism on generics this way, because while a feline is a child class of animal, so I can always use a feline where I'm expecting an animal, a list of feline is certainly not a child of a list of animal. So it kind of makes sense that I cannot use a list of feline when I'm using a list of animal, just like I was applying polymorphism. In the same way, an array of feline is certainly not a child of an array of animal. So you will probably conclude that even the call to this function is going to fail. But if it was like that, why would I be asking you? And in fact, what happens is that if I try to call f-array passing my feline array, the call actually succeeds. There's nothing wrong from the compiler point of view in doing covariance with arrays. So, second important point, arrays are covariant. I can always use an array of a child class when an array of a base class is expected. And now maybe you will be a little bit confused and you will say, why this difference? Why there's such a discrimination between list of animal and array of animal? And also, I thought that actually using a generics like list of animal was an improvement over using a simple array, or something more flexible than using a simple array. And in this case, it actually seems the array is the most powerful data structure, because I can do covariance on it. Well, usually if there's something that's forbidden in Java, there's a good reason, and the reason is that if it was allowed, it would introduce inconsistency, it would introduce the possibility for bugs. So let's see what could go wrong if we were to allow this kind of call and try to do naive covariance on generics. Well, let's see flist. Actually, if I were doing just this, nothing would go wrong. But, well, there's nothing that can stop me, for example, to do something like this and say, I also want to add something to my list. So I want to say la.add, and I want to add, yes, right now, thanks to polymorphism, I can add animal, but I can also add feline, and I can also add tiger, and I can also add little doggy. So, for example, let's say that I want to add my new little doggy. And you can probably understand that this is very, very wrong, because actually what gets passed right here to the function flist is what? It's felines, and felines is a list of feline, and we just put our poor little doggy inside a list of very aggressive felines. It's not gonna fare very well, I'm afraid. Well, actually, jokes apart, of course, the problem is that we should be guaranteed that this array list of feline will only and always contain feline object. That's the whole purpose of having a generic type. But being able to do covariance on the generic type just defeated the whole purpose of having a list specialized on a specific type like feline, because we were just able to put inside whatever we want, like for example a little doggy. So now at least we know why it's wrong to do, let's say, naive covariance with generics. Let's say just ignore the problem and try to pass a generics specialized on a child where generic specialized on a base class is expected. But the other question is, why is it allowed on arrays? Can I do the same mistake when I'm using an array? Well, it turns out that I actually can, because the compiler will not stop me if I say, for example, AA of 0 equals new little doggy. And so I'm doing exactly what I was doing before. The function f-array is passed this feline array argument, and so it will actually work with an array of felines. And here I'm putting a little doggy in an array of felines. That shouldn't happen. So why is it allowed here with the array and not with the generic, with the list of animal? Well, the answer lies in the fact that generics are only an artificial trick of the compiler, are only a mechanism that works for the compiler. The virtual machine doesn't know anything about generics. The type list of animal does not really exist as far as the virtual machine is concerned. It's only something that the compiler knows. It's only something that the compiler checks. Generics are only something that the compiler uses to guarantee that our code is more consistent, but the virtual machine doesn't know about it. This is actually called type erasure, meaning that at runtime the type of generics do not exist anymore. The difference with the array is that the array instead has a type that is known to the virtual machine. The virtual machine is perfectly capable to distinguish an array of animal from an array of felines, from an array of little doggies. And so it will be able to react immediately and raise an error immediately when it sees that I'm misusing an array and putting something in an array that is not of the class that is supposed to be in that array. So what I'm expecting is that when I execute this code and I pass it to it an array of felines, and a runtime exception will be thrown. Let's see if that actually happens. So let's comment out this function that of course is not allowed, this call to function that is called is not allowed, and let's try to execute my code. So right click and let's run it as a control. And there we go. Here is our exception. Isn't it nice when we are actually happy to see an exception? Well, in this case we should be happy because we see that the error surfaces immediately. We immediately have feedback on the fact that we have made a mistake. So, even though it actually opens the door for a mistake, covariance on array is allowed because even if I make a mistake, it's going to be obvious immediately. While if I make a mistake here, well, this kind of mistake maybe will reveal itself much later when I'm trying to see what's inside this list and I make wrong assumptions about what I'm expecting to find. So, what we found out? Well, we found that naive covariance is not allowed on generics, while it is allowed on arrays, even though it can bring problems. And now we have to find out if there's actually a way to allow covariance with generics. And of course there is, because otherwise I wouldn't have probably made a video about it after all. And the way is to actually change the parameter that I'm using here. So I will never be able to pass a list of felines where a list of animal is expected, but I will be able to pass a list of feline where a list of question mark extends animal is expected. This syntax can be a little scary for a question mark, but I think it's actually very intuitive. And because it actually means I don't really know what kind of class this is. All I know is that it extends animal. And now you can see that if I go here and uncomment this line, the call is actually going to work. I can pass a list of feline to a list of whatever extends animal. Yes, of course, because feline extends animal. And I can still do my little for each loop, but wait a second, there's something wrong here. Well, of course, with flexibility, I always have to pay some price, and here the price is that I'm not allowed anymore to add to this list. So I can basically read from it, but I cannot write to it. And if you think about it, it makes a lot of sense, because if I'm not able to determine what kind of what kind of animal is inside this list? Well, there's no safe way of adding animals to this list. So I have to give this up. But this is still going to be a very useful function, because of course not every function that works, for example, with the list has to modify the content of the list. And so now I've achieved covariance on the generic type, and this can be very useful. I want to stress this is not an academic topic of interest only to language lawyers, no? To Java language lawyers. It is actually very interesting thing to know, because if you understand the syntax, you will be able to understand better the Java API of the libraries that you use, because they frequently use this kind of syntax where they work with generics, and also you will be able to write your own API in a way that's more flexible. So in this case, for example, if you're writing a function that works with a generic element and it doesn't do any writing, it makes a lot of sense to use a covariant type. So now we understand how covariance works with generics and how we can achieve it, and what we have to give up to achieve it. What's left is to discuss how about the other way, how about the contrary, how about contravariance, and that is how about being able to pass a generic that specializes on a base class to a generic that specializes on a child class. Let's make this a little bit more concrete. Let's make another function. Let's say public static void, and we'll call it, for example, I don't know, control list. And this is going to take a list of tiger, input, and there we go. And now my question is there a way to use this function and pass not only a list of tiger, but for example a list of feline? Because as usual we want to avoid duplication, and maybe it could be useful to have a single function that works not only with list of tiger but also with other kind of animals. And let's try the naive approach, which of course is not going to work. And so my function is called control list, and we say control list of my list was called felines, and of course it doesn't work. So yes, okay, compiler, I know I cannot pass a generic that specializes on a base class to a generic that specializes on a child class. This actually makes a lot more sense than the opposite situation, but it can still be a useful thing to do, and it can still be fixed. So we can actually achieve contravariance of the generic type. That is, we can be able to substitute a superclass when we expect a subclass, and sometimes it can be useful as well. And the trick is similar to the one that we use to achieve covariance. What we'll do is to use again the question mark, but now the keyword is super and not extends. So now we are saying that this function is able to receive list of tiger, but also of whatever type that is a super type of class tiger. So we'll be able to pass a list of felines, we'll be able to pass a list of animals, we'll be able to pass list of objects. And in fact now the call to control list with a list of felines is actually working quite fine. What have we given up here though? Because probably we also have to pay a price to achieve contravariance. Well, let's think about it for a moment. If we are not sure what is inside this list, how can we read it? If I say, for example, input.getZero to pick up the first element in the list, what do you think will be the type that is returned from this get method? Well, it is basically whatever type is a supertype of tiger, but in fact the only reference that I can use here that respect this constraint is object. So all I can say is object obj equals input get 0. Any other kind of reference will not be allowed without without forcing a cast. And this actually makes a lot of sense if you think about it, because as I said before, we cannot be sure that inside this list we have actually animals. We could also have object in the, let's say, in the worst case. So yes, if we reason about what actually gets passed to this function, then we could do a force cast, but we know that this kind of code is not clean, is very brittle, is very fragile. So if I'm forced to do reading from the list, it's probably a bad idea to use contravariance in the first place, and I should probably rethink my design. A final question that I could ask is, can I do contravariance with arrays? Just for because we were discussing covariance of arrays before. Well, it turns out that I cannot. And we can verify this very quickly, just creating another function, and we'll call it static void contra array, which will take an input and let's say a tiger array. And let's see if we can call this function and pass in, for example, our feline array. Our feline array is called feline array. The function is called contra array. So we'll say contra array of feline array. And it doesn't work. So we cannot have contravariance of array. So in the end, generics type are actually still more flexible than arrays, because we are able with the special syntax to achieve covariance and contravariance on generic types, but with arrays we can only have covariance, though we can have it, let's say, naturally. So, to sum it up, covariance and contravariance in generics means to be able to use a generic that specializes on a child class where I'm expecting the same generic that specializes on a base class. And to achieve this, we cannot just use the generic as it is, but we have to use the special question mark extends my base class syntax. Then we've seen that we can also achieve contravariance, that is having a generic that targets a subclass, but we're still able to call it passing something that is actually a generic that specializes on a superclass, like for example here on the feline class. We've seen that to do this we use the special syntax question mark super my subclass, and we've seen that the price that we pay is that we cannot easily read from our generics, but we can certainly write to it. For example, we can certainly write what? Well, types of the tiger types. So, for example, we could say input dot add. Let's use the simplest. So, for example, we could say input dot add new tiger, and that works perfectly fine. Can we add another class in the hierarchy? Can we add, for example, a feline? No, we can't. Why? Because for what we know, we could have been passed a list of tiger, and so adding a superclass inside this list would not be correct. So no, we cannot do this. We cannot use a feline in here. See? But it can still be useful to have a function that maybe removes some element or adds element of the subclass that's mentioned here in the parameter. And Finally, we also mentioned that for arrays are naturally covariant. So when I'm expecting an array of animal, I can surely pass an array of feline, but I have to be careful because then I'm defenseless against this kind of mistake where I misuse the array. But this hopefully it's not gonna happen often, and if it happens, it's immediately made noticeable by a runtime exception. So I hope that I've been able to explain to you the generics covariance and contravariance, what these terms mean, and especially why they can be useful, so you can go on and apply these ideas to your own code.